Welcome back to a new video. Today's topic is power load calculation. In any project, you need to give a document to the electrical discipline to identify how many cables and the power required on each one of those cables. This document is, we call it sometimes a load list. You can call it anything else. We have control panel, and that's what we need to look inside it and see how many cables we need. In our cabinet, you can have a PLC, you can have a DCS component controller, and you will have an auxiliary power supply and other stuff as well. So our users or our consumer are PLC and its power supply, CPU IOs, the network switches, protocol converters, HMI, relay and contactors inside the cabinet, a power supply, auxiliary power supply, the light for the cabinet, fan, a heater, an AC socket. From the electrical perspective, they will supply us with an AC, one cable or two cables, maybe coming from a UPS or a generator or a DC. We will have to identify the number of cables and the power on each one of them and the source. In our system, you have an essential component and non-essential component. Even the whole PLC may be considered non-essential. But in a DCS or a PLC, most of the time you said the PLC and HMI and the auxiliary power supply are essential. And the non-essential are the fan, the light, the heaters in the cabinet. Typically, if you say we have essential and non-essential users, then you'll see we need a UPS or a generator feed for the essential part and maybe a utility feed for the non-essential. In a PLC, you can have one PLC, maybe one and one redundant, and also the auxiliary power supply. You may have one or more auxiliary power supply. If you have one feed feeding all of them, then you will have the power distribution from one cable to everything. But if you have two feeds, that means one feed will be for PLC 1 and maybe the auxiliary 24 volt power supply 1, and then the feed number 2 will go to PLC 2 and the second power supply. The feed number 3 will say go to all my fan and lights and heaters. This redundancy in the feed will provide us with more reliable system. This document, which we call it now load list, we will not include in this document any internal calculation. The electrical discipline doesn't need to know anything about how we calculate the 24 volt or how we do our internal calculation. Now we will talk about PLC configurations. PLC can come into a different versions. One of them is a block or a break, which you have the power supply, the IO, the CPU in one piece. Others with a chassis, you can have a CPU and IO. Sometimes you have a power supply on the right side and a redundant on the left side, sometimes only one, but it's one chassis. You have the power supply separate from the CPU. The last configuration is a power supply and the CPU are one piece. They are not two pieces. Here you can see this is a CPU and a power supply. In the next base, it's a power supply only. Now, some companies, they provide you with a very nice table which will say if you have this type of PLC or CPU, that's the power we need or the consumption of this CPU. So this is 50 VA from 120 volt AC. That's your power consumption. So now you don't have to do anything. You just go and give this to our electric. But we need to verify this value. Is it enough to supply the power for all our IO or not? So we have another internal thing to do. You need to calculate your consumption from all your system to make sure that the power supply is adequate for this service. Most of the PLCs, the power supply will provide 5 volt. Very few will provide 24 volt as well. The 5 volt will go to power all the electronics in our cards. If the power supply in base 1 is not adequate for all our I/O cards, we have to move some of the cards to a new base with a new CPU and leave the rest empty. Some companies, and what I'm doing now is I'm using Automation Direct as an example here. The channel, we don't have any association with Automation Direct, but I use it because I know my way inside their website, inside their documents. I've been using them, and you can see most of my pictures includes their product. So they provide something nice. They provide the bases. Each base actually has some electronics. So the base itself will consume 80 milliamps, and it doesn't need an external power supply. Those cards here and here, they required this much of 5 volt milliamps and this much of an auxiliary 24 volt. If you have your PLC supplier providing you with a nice table like this, all you have to do is you look at how many cards from this type, you know exactly what is your external power supply requirement. And you can calculate if your power supply in the base, which is a PLC power supply, is enough. But if you don't have such nice table, what are you going to do? You have to go to the individual card. Here I'm showing you what is going on here, and this is my card. You can see they show us on the termination that it needs an external power supply. In each channel of them, they showed that you need a power supply, an external power supply. Now, this is a DC input card. The power supply will provide to the contact or whatever input device here, and it goes back into your card, internal card. So you will have internal resistance and you have a maximum current through this channel. So here it says input current is on 24 volt DC is 5 milliamps. So if I have 16 digital input, you multiply the 16 by the 5, which is whatever it is. This is your milliamps from the external power supply or my auxiliary power supply. This card needs 100 milliamps from the base. So this one goes into my external power supply or auxiliary power supply, and this will come from the PLC base power supply. Let's look at a DC output. In this, you can see they showed us that we need two types of power supply. The first one is common for the whole card, and the second will go for each channel. So the first power supply will provide power to the optocoupler, which powers the base of this transistor to drive the current through our load. You can see here two types of requirement. The first one is 200 milliamps from the base, and then the external power required 125 milliamps on the 24 volt. Now you can see here something else also. The maximum current is 0.5 amps per point, but it's 3 amps are common. That means this card 8 channels and 8 channels. Other cards may be 4, 4, 4, 4. So assuming this card is 8 and 8, so the common here is a 3 amps for 8 channels. So 8 amps is your maximum on this loads. So that means my 24 volts need 3 amps for half of my card. So I can consume up to 6 amps on my system. That's per one card. So this is the maximum you can consume or your load can withdraw from your card. But is your load really required 0.5 amps or less or more? It's up to you. Now, if you have a relay and this relay coil required 0.05 amps, you can forget about this, and you said my users is so and so and so. That's a lot less than what's in here, but this will give you the maximum you can draw from this card. The relay card actually one of the heavy load on the internal power supply from the PLC. The reason is you have the coils inside those relays, and you can see here this card is 8 relays only, but they need 550 milliamps. So the card will consume this much if you energized the whole 8 relays. Now we did not consider the load which from the contact itself. You can see here we have 2 types of requirement. One is the power from the base, and then the power driving your load. This is AC or DC because this is a dry contact, so you can calculate your loads and you can see the consumption on all of them. So let's move to an analog input card. You can see here they specified that this card requires 24 volt external power to power the card. If you look at the 420 milliamps here, 2 wire, there is no power supply here. That means it's already calculated and consumed, supplied by this by this power supply. So assume you have 8 channel, each one of them 420 milliamps, then the consumption of this card from the power supply is, let's say, 22 or 25 milliamps multiply by 5 or by 8 or by 16 or by 4, depends on your card capacity. For the analog output card, again it's exactly the same. So let's look at an odd items now. Magnetic flow meter, ultrasonic flow meter, and so on. They need an AC power. They will give you the signals, but they need a separate AC power. A 4-wire transmitter, we may need an AC power supply. The reason that they need power supply, a separate power for them, because the power consumption in the electronic, in the system here is too much than the 20 milliamps. So assuming you have an AC power supply, from my PLC panel, I will use the UPS feed to power those electronic, and I will make sure that they come from my cabinet. Our calculation sheet, we will look at it now. We will discuss how we can calculate and check the PLC power supply, and also we will calculate the required auxiliary power, and then we will calculate the total panel power, which we will send it to the electric group. This is a typical sheet for calculation or the load list. You can use it. The cover sheet, you need to put the project name, blah, blah, blah. Now, the PLC power supply. If the system did not give you a guarantee that your chassis power supply can provide power for all of them, then you need to do this. Some companies, what they did is they looked at how many chassis slots here, 8. What is their maximum power consumption card? Let's say a relay. Then a relay, if you have all of them from a relay, then 0.5 amps from the relay card multiply 10, that's mean 5 amps. So my power supply will be sized for the maximum. Some other companies, they didn't do that. They will ask you to do this calculation and the check. So you will have to put here in the base will consume some, as we saw before, some milliamps from the 5 volt. Then you will put, say, 80 milliamps. You can use milliamps or amps. And then CPU, if you have a slot 0, have a CPU extension or anything else, you add what's required from the 5 volt and the rest. And then you can do the total here, and then you can look at what is the available from your power supply. So my power supply can provide me with 20 amps on the 5 volt, and it doesn't provide anything on the 24 volt power supply. There is no 24 volts here. And maybe this is the requirement for this slot 1. So slot 1 may required from the auxiliary power supply maybe 0.5 amps. So from this sheet you can calculate exactly how many auxiliary power supply requirement from the base 1. So this is part 1. If this power supply and the chassis can provide power for all of them, then we are okay. And that's why it's conditioned here. If this one, let's assume 1 gives me 1 amps, it will be okay and green. If it's not, it will be yellow. Let's move to the auxiliary power supply. The first item already calculated from previous sheet, the power supply, auxiliary power supply requirement from the sheet 1. And then you can add all your analog input, digital output, network switches, everything you did not find in the rest of the PLCs and things. The auxiliary power supply sheet here is the 24 volt power supply, which will provide power for your cards, I/O cards, for your inputs, outputs, for your network switches, HMI maybe, indication lamps, everything which is need 24 volt. We calculated in the previous sheet some power required to run the cards and try an I/O and so on. If your I/O is already calculated in your card, you don't have to include it here. If it is not, you include it here. And then all of them, you see how many milliamps or watts, it depends on how you calculate it, and you know exactly what is your power supply. So this sheet will define our power requirement for the panel. Anything which has been calculated, included in the previous sheets, will come here as a single number only. Meaning you have a power supply 1 and 2, you already know is power requirement. This is 50 watts, this is 50 watt. Okay, good. 50 watt and 50 watt. So let's say 50 and 50. Now they will be from a different feed because it's a redundant system. So you need to go into feed 1 and you said 40 here, 100 here, 100 there, 50 in this, yep, 50 in this, and 50 in this. CPU, communication card, digital input, digital output, all of these already included in the PLC sheet. So I don't need to include them here. You have a power supply, the auxiliary power supply. You got two of them. Each one is 100 watts. One from feed 1, one from feed 2. Interposing relays. The interposing relays already included into the consumption of your digital output card, or had been included in your DC power supply, so you don't have to include them here. Your solenoids, assuming you're running a solenoid 120 volt AC, feed the contactor and so on, and then you need them here, you can add them. So in summary, everything which is not included in this power supply or these power supplies, you include it separately. Your HMI, yes, I have one HMI, I will use it from feed 1. My fan, it will come from my utilities. So you will include the fan, let's assume whatever it is here. So at the end, you will find 3 values, 1 for UPS 1 feed, 2 and 3. Of course, in your design, maybe you have only 1 feed, so you don't have to include all this data, because I don't know what is your system. I'm giving you all the options. So this is what you're going to give to our electrical group. You will give them the cabinet or the panel, tag number, the location, maybe the description, more stuff, so they know where is this cabinet, maybe which room, control room, maybe it's in one of those substation. And then you will tell them, I need feed 1, feed 2, feed 3. Feed 1, I need this much watts, this voltage, this current, and so on. So this is what they need to design their system for. Like your feed will come from here. By this, we conclude the video of today. Please like and share, and see you in the next video.